Hello, everyone. Welcome to today's webinar. We will wait a little bit to give all the attendees the chance to log in, and then we will start. All right, so we are getting more and more attendees, but let's start now. So welcome everyone to today's webinar. What is model-based systems engineering? Thomas Marchand, who's with me today, is our CATIA cyber systems specialist, and he will give you an overview about MBSE. And he will also answer your questions after this presentation, which you can already post into the Q&A section. Thomas, the stage is yours.
Thank you, Honorata, and welcome to everyone for this webinar. I will start and share my screen. I think that you should see my screen right now. Okay, so let's start. And here is the topics I will speak about today. Before introducing MBSE and system engineering and model-based system engineering, I will first speak about the industry challenges. Okay, what are the challenges and why we go to system engineering? And then I will present some general concepts of system engineering and MBSE. And after that, I will present, okay, it's good to go MBSE, but where to start? What are the tools and the method that we need to adopt to execute some MBSE approach for the projects. And I will finish with a few takeaways from this presentation. But before I present I start my presentation, I will ask you what is your level of adoption of MBSE in your company? Is it completely new for you, or are you maybe you have already some experts doing MBSE and maybe you have already you have a lot of experts and every project are they use MBSE. So I have launched the poll. I think you have, yes, you can answer. I see that you have started to answer. That's good. I will just wait one more minute, maybe, to let the time to everybody to answer. Okay, I will close the poll because I don't want to take too much time, maybe a few seconds, and then I will close because I see the attendance. Okay, I am sharing the results. I don't know exactly because it's the first time I do it with Zoom, so I don't know exactly what you are seeing. But if I look at the results, I think that okay, you are not. Most of the people here, they know about MBSE, but they have started to study it, but not to implement it. So that's good. I think that you are the good audience for that session. So let's start and let's speak about the challenges. Why system engineering is a good approach for you. So I think it's okay. First of all, I think it's pretty clear that I still see the sharing, the poll. I don't know if it's the case for you.
I have turned it off and should be gone now.
Okay. Yeah, so the first challenge is about complexity. Okay, that's clear that for several years we have seen a huge increase in product complexity with the introduction of software in every products, even in a wash machine or in fridge. We have smart and connected elements, and I don't even speak about smart cars, let's say connected cars, that now they receive more updates, and they receive updates like your smartphone. So we have a lot more complex system with a lot of connection, a lot of interfaces, and so this is why it's difficult to conceive and to design these systems. The thing is, when we have a lot of smart system, we want them to, actually we delegate to them a lot of things. We want them to help us in our day-to-day life. And so just think about what we will see with autonomous car in the coming years. It's nice to have autonomous car on the road, but we want to stay safe. Okay, so the challenge here is that we want to develop new complex systems, but we have to face more stringent standards. Okay, we have a big difficulty to prove that this complex system is still safe. Okay, this is a very big challenge. Of course, this is not new. We still have everybody wants to be the first on the market and to deliver a product with the right quality and the right cost. Okay, we don't want to over expense. And here, the idea is that during the development process, we introduce a lot of defects, okay, a lot of errors. And what we see is that, what you observe is that these errors, they are mostly introduced during the early phase of the development, during the specification. But we detect them and we correct them very late, let's say, during the integration, okay, when we bring back every pieces together and we try to validate the system. This is where we detect the errors and we correct them, but at that time it's quite expensive. And so the idea is to work on that area, to work in the early stage in order to detect and correct the errors. My last point is about collaboration. And because it's clear that if we want to develop complex system, we have to bring everybody, to bring every specialist, every expert in the same room. Okay, so for example, if you think about the emergency braking system of your car, it's clearly not just a mechanical device. It's something that has to detect and analyze the situation, to take a decision, to activate the brake for you. And so we need a lot of expertise from electronics, software, electrical, mechanical, and so on. So we have to bring everybody back, in the same room, so to break the silo. Okay, so you have guessed it, system engineering can help you to face these challenges. So what is system engineering? I will start with a short definition. System engineering is a holistic and systematic interdisciplinary approach and means to enable the realization of successful systems in large projects and connected worlds based on multi-industry best practices. This is a definition that comes from this standard, ISO 15288. So if you don't know it, it's the main standard for system engineering. And I present here also the INCOSE System Engineering Handbook. INCOSE is the International Council of System Engineering, which promotes system engineering practices around the world. And so they describe quite well all the processes, the technical processes that we apply with system engineering. Okay, so just if you want to know more about system engineering, these are two good sources of information. So, okay, what is system engineering? So remember, as I explained before, one of the challenges is to limit the number of errors we will introduce, okay, at the start of the project. And so we have to spend more time, to spend more energy to understand the problem, okay, before jumping into the solution. And again, because we are our system, okay, we have more and more connection. We want a smart system, and so we have more and more usage. And so when we work on this problem analysis, we have to keep a strong focus on the customer needs. Okay, we put the user at the center of the analysis. But of course, I said that it's an holistic approach. And so during this problem analysis, we cannot just focus on the operation phase. We have to look into the whole life cycle. And especially today, when we speak about, let's say, the disposal of the system, it's okay, we cannot say anymore disposal, but maybe more recycling. And so in order to have a sustainable approach, okay, sustainable development, we need to think about everything, okay, where we get the materials and what we will do at the end with our system. Okay, I don't speak about the V-cycle. I think it's pretty clear for everybody. This is the V-cycle of system engineering. This one is coming from INCOSY. I will speak again about that one later. So in practice, what we do when we do system engineering. So I will present some of the concepts, basic concepts that we execute, let's say that we do during the system engineering approach. First, we have to cope with the complexity of the system. Okay, we cannot manage everything at the same level. Okay, we cannot stay at the system level and try to understand all the function. We have to split and to decompose the system in smaller pieces, in subsystems. And you can do that a lot of time. Okay, it depends on the complexity of the system. You can do it once, twice, n times until we have the smallest part of our system. Okay, so we will have several system elements. And the idea is that each time we go from one level to another, we'll keep the traceability. Okay, so we define our system with some requirements, and we propose an architecture that satisfies this requirement. In this architecture, I will define new subsystems. Okay, and each time I go in the next level, I create new requirements that are derived from the previous level, and the same for my architecture. Okay, so I inherit, I don't know, interfaces and so on from the previous level. Okay, so we split everything, and then we can manage the complexity more easily. Okay, now that's good. We have, let's say, our product breakdown structure. We know how the system is decomposed, but the thing is that we don't do it right the first time. Clearly, we need time to mature, to get a better idea of what we want to do exactly, what kind of system we will produce. And so we let's say, start from a very high level of abstraction, and we will introduce more and more details during the process to reduce this abstraction, okay, until we reach a complete model, well-defined, with the well-detailed interfaces and so on. Okay, so decomposition, traceability, abstraction. This phase corresponds to the left side of the V-cycle. Okay, so it's a top-down approach. We analyze the problem until and we decompose until we have the implementation of each part. And then we have to integrate back everything. Okay, we take back every pieces, we put them together, and at each level, we have to work to do the verification. We have to verify that what we have produced is compliant with the requirements. Okay, and we do it at every level until the last validation at the system level. Okay, so very basic concepts. To sum up, in order to master the complexity, we use system engineering that connects the dots between all the disciplines. Okay, we can do concurrent engineering because we have split everything, and we do it at different levels and at different stage of the process, thanks to this abstraction. Okay, so that's for system engineering in general. Okay, but what about model-based system engineering? And okay, we see artificial intelligence everywhere. Everybody is using ChatGPT for everything. So I couldn't resist, and I tried to ask ChatGPT what is MBSE. Okay, so I asked him, can you describe what is MBSE? I will not read the full answer, it's not important, but some part of this answer was quite interesting. For example, this one. Okay, in a MBSE, we use model as a central means of representing, designing, analyzing, and managing complex systems. And I was very happy to see that because it's quite close to the definition from the INCOSE. Okay, so again, this INCOSE, in their own book, they define model-based system engineering, and they explain that it's just a formalized application of system engineering through the use of model, and to support system requirement, design, analysis, verification, and validation activities. And we do it throughout all the life cycle phases of the system development. So this picture, to illustrate that, this picture is a bit old. It's coming from INCOSE and the OMG when they introduce the SysML, the system modeling language, in order to create a system model. But the idea is that one. We can do system engineering with document. Okay, this is a document-based approach where everybody exchange data. Actually, when I say data, they exchange just document, Excel files, Word, PDF, whatever. And so they produce a lot of documents. They spend a lot of time to update them. They spend more time maybe just to manage the document itself and not the content. And so the idea is to move to a model-based system where we put at the center the model itself. And if we need, okay, if we need to produce a document, it's still possible, but we will generate them thanks to the model. Okay, so maybe some of you will say, okay, model-based is maybe it's nice, but we are doing system engineering for a long time and it works. We have done a very complex system, I don't know, aircraft, cars. So why moving? I'm pretty sure that you have lived one of the, at least one of the situation I will describe here. So this is something we, some statements, these statements, they come from a work we did with Kongsberg Aerospace some years ago. And it was, okay, these are the statements that came when we speak about document-based system engineering. And so, for example, I cannot see the big picture in the document. So yeah, it's very difficult to, when we have a lot of design document, a lot of analysis, so a lot of reports, it's very hard to get the big picture, to understand everything, you know, to have this capability to zoom in or zoom out in your system, because you have to browse a lot of documents. And even with a new search engine, okay, it's very difficult to find the right information. Sometimes we are looking for something, we don't know exactly the term or whatever. We are looking and we spend a lot of time just to find a piece of information. And as I said, we spent a lot of time to write the document and to rewrite them. Okay, when we, for example, we want to deliver a report to a supplier or to a client, we want to write everything in the same report to have a nice, okay, a nice specification or a nice report, a nice justification document, for example. And we don't want to give 10 different documents with references to another analysis or whatever. So we rewrite everything to have only one doc. This is, again, a lot of time. And of course, very difficult to keep everything up to date. So I think that you are convinced. If not, just think about what we lived some years ago, 30 or 40 years, 40 years ago. By the way, CATIA was introduced 40 years ago. When we moved from the pen and paper design, okay, mechanical design, to computer aided design, and I'm pretty sure that nobody wants to go back. Today, it's obvious that we don't want to do that anymore, and I think it's pretty the same with model-based system engineering. Okay, so now I have spoken about why going to system engineering to MBSE. Now, what are the benefits of using models? Again, it's the same answer of ChatGPT. Again, he said two interesting things that I will describe in the next slide. The first thing is about providing, okay, when we apply MBSE, we provide a unified and consistent representation of the system that can be shared across different stakeholders and engineering disciplines. So remember one of those challenges I've presented at the start of this presentation. I have spoken about breaking the silo, okay, about collaboration. This is exactly what is presented by ChatGPT here. It's what we call the digital continuity. We want to share unified and consistent. This is very important that everybody is sharing the same level of information across every disciplines. Okay, so this is how we bring together in the same room. Okay, it's not exactly in the same room, but we bring them on the same model or models. You can have several models, but we bring them on the same platform and we share the same kind of information, same level of information. The second point is about a better understanding of the system and the requirements to identify potential issues. This is the important part here. Issues and conflicts, and evaluate different design options. So this is, to come back to my challenges again, this is where we try to detect these defects, these errors that we introduce during the specification. The idea is to have a better understanding of the problem and not to wait after the integration to verify and validate the system. Okay, we need to check everything at every stage of the system. And this is something that is possible because with a model, you can simulate it, you can play with it, and it's clearly more, it's easier to understand how my system will behave and if it's a good direction or not. I have a third point. Okay, ChatGPT didn't say anything about it, but it's very important also. It's about capitalize and reuse. Okay, it's with model, it becomes very easy to reuse elements. Okay, to reuse your specification and reuse your architecture. It's very hard with document. Okay, with document, when we say reuse, we speak about copy paste. But with model, it's a new dimension. And what we see here is also what is behind is product line engineering. Okay, if you want to capitalize and reuse, you have to think about your product line and how you will create one architecture that can answer to several needs. Okay, and this is how you can reduce the cost of the development. Okay, so now what are the method and the tools how to go to MBSE? This is the last time I will speak about ChatGPT. So for that time, it's about the enablers of MBSE. Okay, and for ChatGPT, engineers, they use a modeling language, tools, and techniques to create digital models. And actually, it's quite good because this corresponds to the 3 PRs. Actually, in Dassault Systèmes, we say that we have 3 PRs for an MBSE solution, which are the modeling language. So for us, we propose the SysML, the system modeling language, a modeling tool, CATIA Magic, that implements this language, and a methodology. Okay, and in our case, our methodology is called the Magic Grid. So just a few words about SysML. Okay, SysML, it's for Systems Modeling Language. It's a graphical language that is actually derived from the UML. It was introduced by OMG and INCOSI, and it was published, I think the specification was published in 2006. So now it's getting old, let's say. And there is a second version of SysML that is coming very soon. So it's implemented as a UML profile. So it means that some part of UML is reused in SysML, but we introduce other elements that were mandatory for system engineering, but not for software. So we introduce other things. And why using a modeling tool? It's because even if you use the right language, you need a model. Okay, you need to create your model. You need a tool, and to check that your model is consistent, that you are using the language the right way. You need a specific tool. Okay, a tool that understands what is SysML, for example. Okay, so like Katia Magic, we have a SysML meta-model compliant database. So yeah, this repository is given by the modeling tool. And just a few words about diagramming tool. Okay, so we are speaking about a modeling tool. We do diagrams. Okay, SysML is a graphical language, and you create the model thanks to diagrams. But the purpose is not to create pictures to illustrate your requirements. Okay, so requirements, diagrams, they are all parts of the model. Don't think about Katia Magic as a way to have a nice picture to copy paste them in Word. It's not the case. You have to work to understand that the model has several aspects, and maybe you will generate several documents from your model, depending of, for example, for your client or for a supplier, will not generate the same level of information. And of course, we can generate document, but not only. We can publish a model to share it through a web browser. Okay, it's possible to share a model without Katia Magic, let's say. Anybody can open the model and parse it. And so the third PR that I have introduced is the methodology. Okay, in our case, it's the Magic Grid. And why it's very important to have a methodology is because even if you are an expert in SysML, you have no guidelines. Okay, you don't know where to start. You don't know exactly what are the views you have to create, what artifacts you need. So it's very important to think about methodology, and there are several of them on the market. And so we introduced the Magic Grid in 2017. So why we believe that the Magic Grid is a good methodology? First, because it's completely compliant with the SysML. Okay, and when I say SysML, with the pure SysML, you don't need any profile. You don't need to customize SysML. You can use it already as is. And by the way, we don't use everything from SysML. Okay, you don't have to be an expert of SysML to use this methodology. But the purpose of it, we just use the basic items, and we can create already some complex systems. Another thing that is very important also is that I have mentioned already this standard, the ISO 15288, so the standard for system engineering. And so it's very important that this methodology is compliant with that. And so we have a mapping that we can map every processes that are described in that standard with the Magic Grid. So if you know already system engineering, you can adopt this methodology, will not be lost because we have the same processes. And of course, we have implemented this method in CATIA Magic, so we have already templates and some help for you inside the tool. And it's not a methodology we develop ourselves alone. It's not a Magic or Dassault system method only. This is something that we presented several times in different conferences, and we tested it with some of our clients or partners. We worked with them and we matured this methodology for several years now. So very quickly, I will present it. So this is the Magic Grid. And so how it works, we have here on that part, we have some domains. Okay, so remember, I said that it's very important to work on the problem first before jumping in the solution. So this is why we have a very important part here for the problem domain, for the problem analysis. On that side, okay, the columns here, they represent PRs. So the 4 first columns, they represent the 4 PRs of SysML. So if you know a bit the language, you know that diagrams are grouped into 4 PRs, which are requirements, structures, behavior, and parameters. And so these are, we reuse these PRs in our Magic Grid. And the last column is about safety. Okay, so remember, I mentioned this safety challenge that we have to prove that our system is safe. Okay, and it's quite good to start to work on that very early in the project. Okay, don't wait to have your okay to have every component, okay, to do your failure analysis and so on. Don't wait to have the detailed design. Start already at the functional level. It's quite important. And so the idea is that each cell of the cellule, okay, from one domain has one aspect, let's say, and we have a view specification. Okay, so each cell of the grid, we recommend to create some kind of diagrams from SysML in order to describe the system. Okay, describe the architecture, describe the function, whatever. I said that we have a mapping from this standard, this ISO standard, to the Magic Grid. I will not present the complete mapping, but just the few main phases, let's say, development phases we have in system engineering, which are the operational analysis. Okay, so the first thing we do is about operational analysis, trying to understand what are the missions of our system, what are the what is the purpose of my system. We refine the stakeholder needs to have a better understanding of what we want. Then we can go to the functional analysis, and so we start to create this functional architecture, this functional breakdown structure, before allocating them to a logical architecture, which is more the structure aspect of our system. The last part of the grid, it's something that we called model-based design. Okay, so I have only spoken about MBSE, but at some point we need to get some, let's say, some expertise from disciplines. Okay, we cannot do everything in CATIA Magic and in SysML. At some point we have to ask for help from electronic people, software guys, and so on. And so this is where we have this transition between model-based system engineering and model-based design, where expertise, okay, discipline expertise will come in the game. And this transition is possible because of the 3D experience platform. Okay, so the idea is that we produce a lot of data thanks to CATIA Magic. Okay, we work on the system architecture, but this data actually they are inputs for other disciplines. Okay, so we need to go. We need this transition from CATIA Magic and SysML to the 3D Experience platform from Dassault System, where we have a lot of application for electronics, software, even for simulation also. I didn't mention simulation, but we have a lot of capability, and we need to do some system analysis with multi-physics simulation, for example. We have Modelica, Daimola with the Modelica standard. And so this is where we connect MBSE and MBD. So let me present this application in a more detailed view. So this is what we call our referential, okay, the CATIA Cyber System referential, where we cover everything from the very high level, so what we call system of systems architecture, down to the component design, okay, the detailed design of for every disciplines. And then we have also everything that you need to verify and validate your project, okay, to do the simulation, hardware in the loop, software in the loop, to do your validation. Of course, for systems of systems, I did not mention that before, but it's based on CATIA Magic also. We don't use SysML. Actually, we use another standard, which is a Unified Architecture Framework managed by OMG also. This is about, okay, we speak here about enterprise architecture, about, yeah, more wider topic than just system engineering. But this is where we start to analyze, let's say, missions, what kind of system, for example, the defense ministry, what kind of system they need to acquire for their capabilities and so on. After we go to system engineering with CATIA Magic and SysML, okay, we do functional and logical architecture, and then we have the model-based design with every disciplines. And maybe you noticed that we have this disposition like the V cycle that I have presented before. And as I said also, we can do simulation at every stage of the development and do this, you know, early validation. I will just try to illustrate that with a short example. Okay, this is an example with an electrical vehicle, just to show this decomposition and how we transit to MBD. For example, so we have this car and we have applied, okay, the magic grid. We have analyzed the problem and produced an architecture. In this architecture, we have the electrical propulsion that is still a complex system itself, so we can do it again, okay? And at that level, we have, okay, my energy module is composed of several elements, which are the battery module and the power electronics. And clearly, this is not something that I will handle with CATIA Magic, okay? So it's the time to switch from SysML to a more specific application that we have in the platform, like electrical architecture, schematics, and 3D design. And this digital continuity is possible because we have a way to connect from this SysML world to the platform. Okay, we can export data and reuse them in the platform. And we have already something similar at the requirement level. Okay, because I didn't mention that CATIA Magic is very good to analyze the problem and produce your system requirements. But it's not a requirement manager tool. Okay, you need another tool to do that, to have this governance and this process, no workflow and so on. And so this is why we have synchronization with Enovia from the platform. So now I will give you a few takeaways, but just before, I wanted to present this paper. Okay, it was something, a paper written by Lockheed Martin and presented in at the INCOSY. And it's very interesting because they explain how they have adopted MBSE, how they have started to work with MBSE for submarines program. And it was, let's say, a progressive approach, and they have evaluated the benefits, okay, of MBSE. You can find the paper and download it, and it's very interesting. Just do it, please. But I want to highlight one of the benefits that they measured, that they have evaluated. This is the number of errors they have detected early. Okay, so again, this challenge, which is very important, detect defects early when it is cheaper than later when it is expensive. So this is what they have measured, 30% more detected before, detected at the early stage. So just as a takeaway, what is Dassault system strategy for MBSE? First, we provide best tools to create smart and connected systems, and by following the system engineering concept that I have presented. Okay, so here we see the composition and traceability. We propose to break the silo thanks to the creation of digital continuity through the different roles and teams involved in the engineering process. And we provide what we call an MBSE experience that allows to execute tests and simulation at any level of abstraction. Okay, so this is something that we call also mod sim, modelization simulation. Every time you create a model, you can execute it and check it, verify that it's what you want to do. And the platform offers much more because they offers also governance services for change management, configuration, project management, issues, and so on. So basic, let's say, governance element we need. And of course, the last point is about openness, because we are convinced that we need to adopt standards. Okay, we cannot just have proprietary standards and for system engineering, because it's about exchanging data between a lot of disciplines. And so we have adopted a lot of standards, but not only we have adopted them, but we work also at the definition of this standard. So why the 3D experience platform is to move from siloed application to the platform, to the 3D experience platform. Just to finish, if you want to know more, we have this community. You can just scan the QR code and connect to this community, and you will be able to exchange with your peers, with experts, with tool experts, and other system engineers that are like you, asking the same question. So feel free to join and to participate. Thank you. Thank you for your attention. I think we have a few more minutes to answer your questions.
And we have plenty of questions. So before we go to the questions, we will have the recording of this webinar available on this community as well that you just saw here, so you can share it with your colleagues and interested peers. And now I would start to answer the questions. So the first one is how systems engineering and configuration management are different.
Okay, it's not that I think you cannot oppose everything. There are two different approach, two different things, but complementary things. Okay, system engineering is a way to tackle the complexity. Okay, you want to understand your system. It's you will decompose it. You will try to define the function and so on. But to do that, you still need configuration management. Okay, when you want to modify your model, I think maybe you have to keep a process, to have a workflow. You want to change something, but maybe you have to ask the authorization, because if you change one interface, you have several impacts on other subsystems. So this is why you need both. You cannot just have just Katia Magic in one side without any versioning system, or I don't know. Both of them are important. And one is about processing, the process, and the other one is more about I describe my system.
Okay. Let's go to the next question. How this is different from PLM like Team Center?
I think it's
Oh, now you're gone.
I think it's quite a close question because, okay, PLM is product line, not product line, sorry, is for your project management. Okay, again, it's a lot about configuration management, about workflow. And so I think it's not different, okay? It's another disciplines. MBSE, system engineering is another discipline that you have to handle. And you will create new model, system model, as you do 3D model, and you have to manage that. And you have to be connected to a PLM. By the way, for Katia Magic, we have what we call the Power BI, because Katia Magic, you can work with what we call Teamwork Cloud, which is the database where you store the project. But now we have introduced what we call the Power BI, and you can save your model, your system model inside the 3D experience platform, so inside the PLM also. And you have the same configuration management, so you can manage your system project, your system model, as you manage other data in your PLM.
Okay, let's move to the next question. Is it possible to use an external repository to be used with the modeling tool?
I'm not sure. In my opinion, the tool and the repository are connected. They cannot be dissociated. Okay, when I speak about a modeling tool, is a repository with several with the CSML rules implemented. So I don't think so. You can connect to other repository for sure. You can synchronize. You can. It depends of what kind of repository you are speaking about, but you can synchronize with other tools. Okay, I mentioned for requirements Enovia, but we have other synchronization. For example, for product line, we have a way to connect also to the platform to get some configuration. Okay, you create variant and options and so on. So it's another repository for variant management. So and we connect to that. But still, you need your CSML model in Katia Magic.
Let's move to the next questions. Can the MBSE models be extended up to after-sales documents like parts catalog or maintenance manuals, as the traceability can enable seamless update to after-sales documents whenever there is a retrofit to the system?
Okay, when we think about part catalogs, I think it's more about let's say PLM. Maybe it's about your BOM, and for me it's not in tools like Katia Magic. Okay, it's more about it's what we do after the model-based design. It's which are the smallest part of the system that you need to build it, and so I think it's not in Katia Magic. It's not where you have to manage this catalog. Of course, you can have a library in Katia Magic. It's good to have a library in order to reuse elements. Okay, but if you want to manage this kind of after sales catalog, I think it's not the right tool. Just do it in I don't know, in Enovia. We have a way to work on this BOM. I think it's better. But of course, everything is connected. You're right, and we have in the platform we have a tool which is called system traceability, system synthesis. I don't remember exactly the name, but we are able to connect everything. Okay, from Katia Magic or from other tools that are not Dassault system. You can connect everything, and you can connect it to your physical element. Okay, to your 3D parts. It's possible to connect everything.
Okay, one more. Is it possible to export all MBSE data that is in the tool in a tool-agnostic text-based manner, such that it is possible to manipulate that data outside the tool and import it again afterwards?
Okay, SysML and UML, they used one standard for data, to exchange data. It's the XMI, which is based on XML, basically. So maybe it can do the job. I don't know exactly what you want to do. When you say tool agnostic, XMI is tool agnostic. It's completely it's related to the language, not the tool. So maybe that can do the job, but we have a lot of we have several ways to export data. We can export in Excel, or we can export in document. So it depends. And in Excel you can import again. It's quite easy to import data from Excel. So
maybe we can say that in the community we have also videos and
yeah.
from our CATIA system talks where you can find the answer to this question, how to import and export these data from Excel and other tools into CATIA Magic. Okay, we have more questions that we can possibly answer today. I need to say that because we have 35 questions waiting. So you will have to ask them again in the community where Thomas has more time to answer all of them, but we can still try to get 2 or 3 more answered. So let's move to the next one. What challenges do you see for companies in introducing an MBSE approach? And do you have any thoughts on how companies can overcome those challenges?
There is something that I didn't mention in that presentation, and I'm thinking about a paper presented in NCOSI. It was about, okay, I said that you have 3 PRs for MBSE, but there is a 4th one, let's say, which is about the people. Okay, and what is very important for you to adopt MBSE is to find the right people in your company that are very interested in MBSE, that are very interested in changement. Okay, to push the change, because this is most of the time it's not a problem of process. It's more about making people change. And so you need to start with a small team, with small experts, a small team of experts. And if they are convinced, they can, spread then the good practice. And we used to say, it's not a slide that I have presented here, but we used to say you have to think big, but to start small and evolve. If you want to do your next big project, okay, the big project your company is relying on for the next 10 years, maybe it's not a good idea. Just, look for a quick win to convince people, and yes, and let people spread the approach everywhere.
Okay, next one is maybe quite easy to answer. When was the Magic Grid layout updated to include the safety and reliability column? How can we stay up to date on changes to the Magic Grid in future?
So the Magic Grid was introduced, okay, like I said, in 2017. It was the first version. We released a second version. I don't remember, maybe it was at the end of 2021. So yeah, 1 year ago, a bit more than 1 year ago. And in that second version, we have introduced that part, the safety part. By the way, if you take actually, we can share the link for you to download the book, because the book is available free in PDF. And if you look at the second version, you will see that, okay, this safety aspect is let's say explained in the annex of the methodology. Okay, we keep the 4 PRs of SysML for the main, let's say, for the core of the methodology, and the safety aspects are treated in the annex. And if you want to stay up to date, I think that the community is the best place to have information about that. So yeah, the community is quite good.
Yes, we will share all the updates on new releases in the community, and you can already find quite a few tutorials, webinars, how-tos for all the MBSE relevant solutions that we provide in the community. Not only CATIA Magic, but also it will be Cameo, Stimulus, and others, and Daimola, by the way, also. So please feel free to join this community. I just need to for all these very specific questions on how to perform certain steps in the process, I would like to ask you to go back to the community as well, because it takes too much time to do a tutorial here right now. I would maybe answer one more question and then we need to stop this webinar. Let's move to this one. Could you elaborate on what a system model is and how we can practically structure and effectively implement a system model in an existing document-based framework? Well, that is quite specific as well, I think.
I don't see the question.
Yeah, it's more about how to do so. This is not so easy to. Maybe this one. Is SysML language a prerequisite to start implementing MBSE using Cameo?
Okay, easy to okay. SysML, Cameo is built on SysML, on UML and SysML. So if your question is, do I need to be an expert in SysML? No, I don't think so. If you have background in system engineering, it should be enough. Okay, just you have to understand some concept of system of the SysML language, but they are quite the same as the one I have presented today. It's about composition, about traceability between requirements, derive, satisfy, and so I think that if you take the book, the Magic Grid Book of Knowledge, and inside there is a step-by-step tutorial, I'm pretty sure that if you just start with that, we will understand everything, and we will feel comfortable to continue with Katia Magic without being an expert in SysML.
And of course, you can find this book in the community.
Yeah.
Okay, thanks a lot. I think we have like 37 more questions, but we are out of time and we cannot answer all of them. So I invite you to join the community where you have the chance to ask these questions in the post of the webinar. And that's it from us today. Thanks a lot for your attention. And I see you in the next webinar in July. Goodbye.
Thank you. Goodbye.